Welcome back to College Algebra. This is section 1.4. In the last video, we covered how to solve a quadratic equation using the zero factor property and using the square root property. This time we're going to talk about completing the square, and that's going to lead us to solving by quadratic formula. So let's get started. Now, we've already said that if it's possible for you to factor a quadratic expression, then factoring is going to be the easiest way to solve that quadratic equation. And if you have an x squared equals k situation, in other words, you have no x term, or if you have a squared binomial equal to a number, then the square root property is going to be the easiest way for you to solve. But if you can't factor and you can't use the square root property, then there's another method called completing the square. And the purpose of completing the square is to force the equation into a situation where you can use the square root property, and then that's how you get it solved. So the idea is to add something to both sides of the equation so that the left side can be factored into a squared binomial, and then we can use the square root property to finish it off. Now this process can get a little complicated, so I'm going to give you steps, and then we will practice using the steps a few times. So to solve an equation that's in the form ax squared plus bx plus c equals 0, in other words, a quadratic equation in standard form, by completing the square, these are the steps. Step 1 is that if your x squared coefficient is not equal to 1, you need to divide both sides of the equation by that coefficient. And that makes sure that your first term is just 1x squared. The second step is to rewrite the equation so that the constant term is by itself on the right side of the equal mark. Now that's different from when we solve by factoring. Remember, when we solve by factoring, we need the right side to be equal to 0. But when we're solving by completing the square, we need the constant on the right side. In step 3, we're going to figure out what we should add to both sides. So the way to find out what to add to both sides is to take the coefficient of x, divide it by 2, and then square that number. Add this square to each side of the equation. That will give you a perfect square trinomial on the left. So factor the trinomial on the left and combine like terms for the other side, and then you can use the square root property as normal to complete the solution. All of this will seem a little better after we've done a few examples together. Now, please do note that completing the square is never the easiest way to use. Factoring is easiest if you can do that, and the square root property is easiest when it applies. However, it's important for us to develop the process of completing the square because we will need it in other places in the course, and also it's going to help us develop the quadratic formula in just a few minutes. So let's look at the equation x squared minus 4x minus 14 equals 0. Notice that this trinomial cannot be factored. If you tried to factor it, you would not find a way to do that. And it's also not a good candidate for completing the square because we have an x term here and we don't have a squared binomial on the left side. So what we're going to do is complete the square. Now remember, step 1 said if the leading coefficient is not 1, you must divide both sides by that leading coefficient. However, ours is 1, so we're in good shape. The first thing we need to do is take our constant and move it to the right side. So we're going to have x squared minus 4x, and now I'm going to leave a space because I always leave a space when I'm completing the square because I know I'm going to be needing to add something to both sides. So leave a space here and then put equals 14 on the right. And now we will add something to both sides. And what will we add? The way to figure out what to add is to take this x coefficient and divide it by 2 and then square that number. So half of 4 is 2, and then 2 squared is 4. So I'm going to add 4 to both sides. Now the magic of this is that now on the left we have a trinomial that can be factored into a squared binomial. So this will factor into x minus 2. This trinomial on the left that you get after you complete the square is always going to factor into the square root of this and this sign and the square root of this. So it's going to be x minus 2 squared. And on the right side, I see that I have 14 plus 4 is 18. So now we can use the square root property. And the square root property says that we unsquare the left side, so that would be x minus 2. And then we say plus or minus the square root of the right side. So that's going to be plus or minus the square root of 18. Now notice that 18 has a perfect square factor. 18 is 9 times 2. And so the square root of 9 is 3. This is going to simplify to plus or minus 3 times the square root of 2. And the last thing we need to do is just move our 2 over to the right side. So of course when we move it, it becomes positive, and we will get x equals 2 plus or minus 3 times the square root of 2. So these are our two solutions, 2 plus 3 square root of 2 and 2 minus 3 square root of 2. Now let's try this one, and I highly recommend that you pause the video and try this one on your own. So please do that. And now, assuming that you have attempted this on your own, let's work it together. So notice that we have a coefficient of 1 on our x squared term. That's good. That means we can go right to step 2. So step 2 is to move the constant term to the right side. So we'll get x squared minus 2x equals positive 2. And now I have to figure out what to add to both sides. So the way to do that is to take half of the middle term. Half of 2 is 1, and 1 squared is still 1. Notice that the middle coefficient is negative 2, but I didn't really bother with the negative because I know I'm going to end up squaring, which is going to turn it positive anyway. So you really can ignore the sign. And now let's add 1 to both sides. And now let's factor the left side. So this trinomial will factor into x minus 1 squared. Remember, it's square root of this term, this sign, and square root of this term. And then on the right side, that's going to equal 3. And now we can use the square root property. So the square root property says unsquare the left side and say plus or minus the square root of the right side. So now we have x minus 1 equals plus or minus square root of 3. Now you're going to add 1 to both sides, and we have x equals 1 plus or minus the square root of 3. Now here's one that is a little more complicated, and it's more complicated because we do have a coefficient here that's not equal to 1. So before our cut it in half and square it trick will work, we must eliminate this coefficient. Let's divide both sides by 9. So we start by dividing all terms by this leading coefficient, and that's going to give us x squared. The 12 over 9 will reduce to 4/3, so you can go ahead and reduce that. So now I have x squared minus 4/3 x. The 9 over 9 reduces to 1, and of course 0 over 9 is just 0. And so this is our resulting quadratic equation. This is equivalent to the first one because all we've done is divide through by 9. Now what we need to do is go through our completing the square steps. So we will move the constant term to the right side. That's going to give us x squared minus 4/3 x, leave a space, and that equals negative 1. And now we need to figure out what to add to both sides. So remember, we take this middle term and we cut it in half, or in other words, we divide it by 2. So half of 4/3, if we reduce this 4 over 2, half of 4/3 is going to be equal to 2/3, and 2/3 squared is equal to 4 over 9. So 4 over 9 is what we should add to both sides. And now let's factor the left side here. The left side is going to factor into this square root, this sign, and this square root. So x minus 2/3, all squared. And the right side is going to add up to -5/9. Now you could do this on your calculator, but I really hope you don't need to. -1 is equal to -9/9. -9/9 plus 4/9 is -5/9. So the right side is -5/9. Now let's apply our square root property. So the square root property says unsquare the left side and apply plus or minus the square root to the right side. So we have x minus 2/3 equals plus or minus the square root of -5/9. Now, if you remember your radical rules, you know that since we have a perfect square in the denominator, it would be in our best interest to split this top and bottom up into two separate radicals. So I'm going to write it like this, because if I have it written this way, in the denominator the square root of 9 will reduce to 3. Also notice that in the top we have the square root of -5, so we know that the negative will come out of the radical and be I. So now we have x minus 2/3 equals plus or minus I times the square root of 5 over 3. And the next thing we need to do is add 2/3 to both sides so that the x is isolated, and we're going to have x equals 2/3 plus or minus I square root of 5 over 3. And the very last thing is really just a cosmetic move, but notice that since these two terms have a common denominator, we may as well write them over one common denominator. So we'll have x equals 2 plus or minus I square root of 5 all over 3. So that way the 3 only appears one time. These two are equivalent. One is not better than the other. You may choose which one you prefer. Now here is a practice example where we have a leading coefficient of -4. If you would like to pause the video and try this on your own, I think that's a great idea. If you would like to walk through this one with me just because these are complicated and you want to see one more, that's also fine. You'll get plenty of practice in the homework. So let's go ahead and look at this one. The first thing we want to do is eliminate this leading coefficient, so I will divide each term by -4. That's going to give us x squared, and here we have 8 over -4, which is minus 2, so we have minus 2x, and on the right side we have 7 over -4, which is just -7/4. Now I'm going to leave a space like we usually do when we're completing the square so that I can add the same thing to both sides. Don't let it bother you that the right side is a fraction. It's really not a big deal. So now let's figure out what to add to both sides. I see that my middle coefficient is 2, so half of 2 is 1, and then 1 squared is 1. So I'm going to add 1 to both sides. And now the left side is going to factor into this square root, this sign, and this square root squared. So x minus 1 squared. And the right side is -7/4 plus 1. Now you know that 1 is going to be equal to 4/4. So you have -7/4 plus 4/4, that's -3/4. Now apply the square root property. The square root property says that we unsquare the left side, so that will be x minus 1, and we apply plus or minus the square root to the right side. So plus or minus the square root of -3/4. Again, I notice that the denominator here is a perfect square, so it makes sense for us to split the radicals up into a radical for the top and a radical for the bottom. That's going to give us plus or minus square root of -3 over square root of 4 for the right side. So now we have x minus 1 equals this expression, but this can be simplified. So notice in the top we have square root of -3, so the square root of the negative will be I. So we'll get x minus 1 equals plus or minus I square root of 3, and that's going to be over the square root of 4, which is 2. And the last thing to do is just bring this -1 over to the right side where it will be positive. So we'll have x equals 1 plus or minus I square root of 3 over 2. And you may be wondering why I left a little gap here. Well, it's because it's just a little awkward for us to have a whole number and then a fraction. So a lot of times what people will do is go ahead and get a common denominator. So I see that this denominator is 2. So I know that to get a common denominator here, I just need to multiply this whole number by 2 over 2. And that's going to give us 2 plus or minus I square root of 3 all over the common denominator of 2. Now, as you can see, completing the square can be a little bit of a burdensome process. It can get complicated. And so back when the idea of solving a quadratic equation was relatively new, mathematicians began to look for a shortcut, kind of a recipe, a formula, a way to see where to put all the numbers without actually having to do all the work. And I'm going to show you how to get the quadratic formula from a quadratic equation that's in standard form. This is not something you'll have to do on your own, but I just want you to see that the quadratic formula wasn't made and handed down. It's a natural result of the process of completing the square. So this is what we've got. If we start with a quadratic equation that's in standard form, and we know that we have a positive a value, in other words, the x squared coefficient is positive, and we go through our steps of completing the square and we leave the a, b, and c in place, then this is what it would look like. ax squared plus bx plus c equals 0. Okay, now we know when we complete the square, the first thing we want to do is to eliminate this a coefficient. So let's divide through by a. And of course the a here will cancel. That'll leave fractions here and here, but this is still 0. So now we have x squared plus b over ax plus c over a equals 0. Don't let the fractions bother you. Just follow along with me. Just bear with me for a minute. Okay, now we're going to complete the square. So this is our constant term because it does not contain an x. Let's move this term to the right like we usually do. And I've left a gap here. Now remember how we determine what to add to both sides? We take this coefficient, we cut it in half, and we square it. So now if I take half of b over a, that actually turns out to be b over 2a. And now if I square that, the square of that is going to be b squared over 4a squared. So that's what I'm going to add to both sides here. You still with me? Okay, now remember we're just using our little completing the square steps. So the next thing to do is to factor the left side, and you might think to yourself, well, I can't factor that, it looks awful. And it does look awful, but remember we have basically a shortcut way to factor this. We always say it's the square root of this term, and then this sign, and the square root of this term, which is easy to get. So it's going to factor into x plus b over 2a all squared, and then we need to add together the terms on this right side. So basically we need to get a common denominator over here. Now what I've done is I've just moved the b squared term to the front and the minus c term to the end so that I don't have a leading negative. So this that you see here is just this written in a different order. Now let's get that common denominator. This denominator is 4a squared, so if I multiply this denominator by 4a, I can have a common denominator. That just means I need to multiply the top by 4a. So nothing really fancy. And now we have a common denominator. So now let's go ahead and apply our square root property. The square root property says I can unsquare the left side. So on the left side I'll get x plus b over 2a, and that's going to be equal to plus or minus the square root of everything on the right. And now notice all I've done here is I've written this with a common denominator. So a times 4a is 4a squared, so that's my common denominator. And then in the top I'd have b squared minus c times 4 times a, which I wrote as 4ac. And now, just like we've seen in a couple of our previous examples, notice that the denominator here is a perfect square. So I'm going to split up the radicals, although I'm not going to write both radicals because I am running out of space a little bit. But you can see that if I have a radical in the top and a radical in the bottom, this would simplify very nicely. So we'll get x plus b over 2a equals plus or minus this radical in the top, and in the bottom the square root of 4a squared is 2a, so that's no longer under the radical. Now let's move this term to the right side, and notice that the denominators are the same. So now I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is the quadratic formula as we know it today. Now the quadratic formula can solve any quadratic equation at all. But it's not always best to use the formula because sometimes there are other ways that are much easier. This formula, although it can work any problem, you can see that it can get a little complicated because we have squaring going on here. We're going to have a radical that you're going to have to deal with. And of course you have this fraction here. You might have to simplify a fraction. So I recommend that you avoid the formula if there is another way that works better. But sometimes there's not. So we do need the formula. Alright, now here it is again. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You should memorize this formula. There's a little song you can sing to the tune of Pop Goes the Weasel, and I'm not going to sing it, but you can go out on YouTube, and if you Google Pop Goes the Weasel quadratic formula, I'm sure you'll find dozens of videos of people singing that little song. But you do need to have the formula memorized. So make sure you memorize this formula and make sure you memorize it correctly. Again, notice that the fraction bar is under the entire numerator. So the entire thing over 2a. Now, I mentioned this before, but again, if factoring or square root property can be used, either one would be easier than using the quadratic formula. The formula is a last resort. And the way I want you to write this is I want you to plug all your numbers directly into the formula without simplifying and do all your simplifying in separate steps. This is going to, 1, show your instructor that you know how to plug into the formula, and 2, it's going to give you an easy reference point to go back to in case you mess something up. So this is really a safe thing to do, and it only takes a second. Do not try to work steps of the formula in your head without writing the whole thing down first. And then finally, make sure that you leave your answer fully simplified. If the radical can be reduced, you're responsible for doing that. And after you've reduced the radical, if the fraction can be reduced, you're also responsible for doing that. Here is our first example. This is a simple one. This one says solve x squared minus 4x equals negative 2. So let's go ahead and recognize that even if we bring the negative 2 over to the left side, we do not get a trinomial that can be factored. Of course, the square root property is not an option here because we have an x term. And so really our only option is to use the quadratic formula. Now that I have all three terms together on the left, I can see that a equals 1, b equals negative 4, and c equals 2. And now let's go ahead and plug into the formula. Now remember, you need to memorize the formula, but I'm going to go ahead and copy it for us here since this is our first time. And the formula, remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now let's plug in. X equals negative 4, because b is negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 2, all over 2 times 1. Okay, now we can simplify. So notice that minus negative 4 is going to be positive 4. And also notice under the radical that negative 4 squared is going to be 16. And then we have minus 4 times 1 times 2, so that's minus 8. 16 minus 8 is going to end up being 8. And in the denominator we have 2 times 1, which is just 2. Okay, so 16 minus 8 we said was 8. And this is where we are. 4 plus or minus the square root of 8 all over 2. Remember that 8 is 4 times 2, so the square root of 4 is 2. We'll end up having here 4 plus or minus 2 square root of 2 over 2. Now notice that in the denominator we have a factor of 2. And notice that in the numerator we could factor out a 2. In other words, this term and this term and this term all can be divided by 2. And so we should do that. And that's going to leave us 4 divided by 2, which is 2, plus or minus 2 square root of 2 over 2, which gives us a coefficient of 1 here, all over 1. Now, whenever the denominator is 1, we don't need to write it, so I haven't even written it here. But 4 divided by 2 is 2. 2 divided by 2 is 1, so this coefficient does not appear. And then in the denominator, 2 divided by 2 is 1, so the denominator does not appear. And this is our final solution. If you wanted to write it out in set notation, you would say x equals curly braces 2 plus square root of 2 and 2 minus square root of 2. Now, I showed you how to check your solutions when we factored, but we haven't talked about checking since then. Now, you can check these. You're going to want to depend on your calculator to do it. So to check, use a decimal approximation on your calculator. What you can do is say 2 plus the square root of 2 is approximately 3.4142. Notice I use the little squiggly equal mark. That's because there are decimal places here that I've rounded off. So it's not exactly equal, but it's way close enough for what we need it for. And then I'll go ahead and say 2 minus square root of 2 is approximately 0.5858. Now we'll check each of these separately. So the first one I'm going to check is the 2 plus square root of 2. I'm going to put 3.4142 in place of each of these x's. So I'll have 3.4142 squared minus 4 times 3.4142. And when I put that in the calculator, I should see that it comes up very, very close to negative 2. And now do the same thing for the other one. So 0.5858 squared minus 4 times 0.5858, and that also should come up very close to negative 2. Now, it takes longer to write it down than it does just to punch it into your calculator. So once you've got these two numbers, you don't really have to write this out. You can just say this number squared minus 4 times this number and see that you get the correct answer for the right side. Since it is so easy to make a little sign error or a little division error when you're using the formula, I highly recommend that you practice this procedure a few times and that you get good at checking your solutions. Now here is another one to try. We will need the formula for this. So if you would like to pause the video and try this one on your own, I highly recommend it. Now I'm going to go through it with you. And so let's say x squared minus 6x equals negative 7. If we bring the negative 7 over to the left side, it will be positive, and we see that this cannot be factored. And so we're going to say a equals 1. B equals negative 6, and C equals 7. And so now we'll plug into the formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Of course, negative 6 is positive 6. Negative 6 squared is positive 36, and 4 times 1 times 7 is 28. So this is where we are. 6 plus or minus the square root of 36 minus 28 all over 2. Now 36 minus 28 is going to be 8. And so we have 6 plus or minus square root of 8 all over 2. 8 is 4 times 2, so this reduces to 2 square root of 2. And now notice that 6 and 2 can all be divided by 2. So that's going to leave us with 3 plus or minus 1 square root of 2 all over 1. And of course we don't need to write those ones because this one is a coefficient and this one is a denominator. Now here is another example, and this one, notice, has a different number for a. Of course, if we were completing the square, that would be a big deal. But when we're using the formula, it's not as much of a big deal. Let's just go ahead and move all of our terms to the same side. I like to keep a positive. So could I move 2x squared to the right? I certainly could, but then a would be negative. I'd rather move these two guys over to the left so that a stays positive. That may be a personal quirk of mine, but I think if you'll try it, you'll like it that way better than if a were negative. So let's have 2x squared minus x plus 4 equals 0. Now you can see that a equals 2, and b equals negative 1, and c equals 4. And so now let's plug into our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now minus negative 1 makes positive 1. And under the radical, negative 1 squared becomes positive 1, and 4 times 2 times 4 is going to be 32. So we're going to have plus or minus 1 minus 32 all over 4. Now you know 1 minus 32 is negative 31. So we end up with 1 plus or minus the square root of negative 31 all over 4. Of course, 31 won't reduce, but we do have a negative under the radical. So the square root of the negative is I. Let's bring that I outside the radical. And we have 1 plus or minus I square root of 31 all over 4. And since 1 and 4 don't share any factors other than 1, we know that this cannot be reduced, and therefore this one's finished. Now admittedly, they are harder to check when you have a complex number involved, so I wouldn't even worry about it. I'd rather work the problem a second time than try to check it with an I in there. But you can just leave this. This is going to be our solution. Here's one you can try on your own, or you can walk through it with me. Let's go through it together. So I see that I have a negative 4x squared, so that means a is negative 4 right now, but I like a to be positive. So the first thing I'm going to do is move that x squared term to the right side of the equal mark. Remember that all of your terms have to be on the same side of the equal mark, and you have to have that equal 0 before you can assign a, b, and c. So I have chosen to move this negative 4x squared over to the right so that a would be positive rather than moving these two over to the left. So now I'm going to say that a equals 4 and b equals negative 12 and c equals 11. So now x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, now notice minus negative 12 is going to be 12. Under the radical, negative 12 squared is 144, and 4 times 11 is going to be 176. So we're going to have 12 plus or minus the square root of 144 minus 176 all over 2 times 4, which is 8. Okay, now doing the subtraction under the radical, 144 minus 176 is going to give us negative 32. So now we have x equals 12 plus or minus the square root of negative 32 all over 8. Of course, notice that this radical can be reduced, so let's look at this. Negative 32 can be broken down into negative 16 times 2. And I did it that way because 16 is the biggest perfect square that will go into 32. If you do it using 4 times 8, you can still get the right answer. It just may take you more than one step. But here I have square root of negative 16 times 2. Of course, the square root of 16 is 4, and the square root of the negative is I, and the 2 will stay under the radical. So the square root of negative 32 is going to reduce to 4i times the square root of 2. Now we have 12 plus or minus 4i times the square root of 2 all over 8. Notice that these three numbers can all be divided by 4. So 12 divided by 4 is going to be 3. 4i divided by 4 is going to be 1i. And in the denominator, 8 divided by 4 is going to be 2. And that's as far as you can go with that one, because now 3 and 2 can't be divided by the same thing. So that one's finished. This is our solution for this equation. Now I want to talk to you just for a second about the discriminant. The problem with quadratic equations and having all these different methods to solve is that sometimes you look at a quadratic equation and you think, I'm not sure if that thing can be factored or not. In other words, I'm not even sure if it's worth my time to try to factor it, or if I should just go ahead with the formula. Well, the discriminant can help us with that. The discriminant is the expression under the radical in the quadratic formula. So the discriminant is just the expression b squared minus 4ac. Now, you know that when you're working a problem with the formula, if the number under the radical is a perfect square, then the radical is going to simplify away. So, if the discriminant is a positive perfect square, then there will be no radical in the solution, and that means that your answers are rational numbers, and that means that factoring is possible. So sometimes when I'm working with a quadratic equation and I'm not sure whether to factor or not, I just quickly calculate b squared minus 4ac. If b squared minus 4ac comes up, say positive 25 or positive 81 even, anything that's a positive perfect square, then I know it's worth my time to go ahead and try to factor it. Now let's talk for a minute about how to choose the best method for solving, and we've touched on this as we've gone along, but now that we have all four methods under our belt, I think it's a good idea just to look back and make sure that we understand the appropriate use of each method. So first of all, if there is no x term, or if there is a squared binomial, you know that that's a job for the square root property. If factoring is possible, then solve by the zero factor property. And if you need to, you can use the discriminant to determine if factoring is even possible. If factoring and square root property are not possible, then you can use the quadratic formula. And that's how it goes. Notice that completing the square is never our method of choice. Now you may be asked to complete the square on a quiz, and in that case you should complete the square. But most of the time, either the square root property or factoring or the quadratic formula is going to be your best bet. So here I have a couple of examples for us, and I want you to think about which is the best method to solve. Notice on this first example we have a squared binomial. That is a dead giveaway that this is a great place to use the square root property. So remember, the square root property says that we unsquare the left side and we do plus or minus the square root of the right side. So now I have x plus 5 equals plus or minus the square root of negative 3. Notice that this radical will reduce just a little bit because negative 3 is 3 times negative 1. So the negative 1 comes out of the radical and we have an I outside the radical. So now I've got x plus 5 equals plus or minus I times the square root of 3. And now the last thing to do is to isolate our x. So now we will say minus 5 on both sides, and that will give us x equals negative 5 plus or minus I times the square root of 3. And there is our solution. Now let's look at this one. This one is negative 6x squared plus 7x equals negative 10. Well, it's definitely not a job for the square root property, and so my choices are between factoring and using the quadratic formula. I guess you could go ahead and jump into the formula here, but let's just take a second and see if this one might factor. Because the more often you factor, the better you will get at it. So I want you to try to factor every opportunity you get. The first thing I would want to do before I decide if factoring is an option is move all the terms to one side. I'm going to have to do that whether I use the formula or whether I factor. So that's not a wasted step in any case. And remember, we like the x squared term to be positive. So I'm going to move these two terms to the right side. Of course, that changes their sign. Now I have 0 equals 6x squared minus 7x minus 10. The 10 was already negative on the right side. Okay, now I'm still not sure off the top of my head if this can be factored, so I'm going to borrow a little help from the discriminant. Remember that if the discriminant is a positive perfect square, that's like a green light for factoring. So the discriminant is going to be b squared minus 4ac, and when I calculate that, I get positive 289. And I happen to know that 289 is the square of 17, and that tells me that it's worth my time to try to factor this expression. It can be solved by factoring. Now, whether I actually want to factor or not is still up to me. And if you get into the factoring and you decide this is just not working out, it's taken me too long, then go ahead and cut your losses and jump to the formula. But like I said, the more you factor, the better you'll get at it. So let's give it a try. 6x squared can be broken down into 3x times 2x. This last term is negative 10. So the negative tells me that these signs need to be different. I'm just going to put a minus and a plus, and if those signs need to be changed, we know we can do that later. And then 10 can be broken down into 2 times 5. Now let's go ahead and try outer plus inner. Outer times outer is positive 15x. Inner times inner is negative 4. 15 minus 4 is 11, so I know that's not right. Let's see what else we can try. Let's try 10 times 1 to make 10. So now outer times outer is positive 3x, and inner times inner is negative 20x, and that's definitely not going to add up to negative 7x, so that's not right either. So now what else can I try? I've already used 5 times 2, and I've used 10 times 1. So there are no other choices for 10, but what I could do is back up, and instead of using 3x times 2x, I could just use 6x times 1x. So let's change this, and now we can put our 2 and our 5 back in there. So now the way I have it arranged, outer times outer is positive 12x, and inner times inner is negative 5x. 12x minus 5x is 7x, so that's great, but I do need the sign to change because we are getting positive 7x. So let's just go ahead and change the signs, and now our middle term will be negative 7x. Now we can get our two solutions. If this times this is 0, it means one of the factors is 0. So if the first factor is 0, that means 6x is negative 5, which means x is negative 5 over 6. And if the second factor is 0, that means x equals 2. So our two solutions are negative 5 over 6 and positive 2. Now here are two more examples, and again, you can pause the video and decide how you want to solve these and attempt it on your own, but now I'm going to go through them with you. So here I have negative 6x squared equals 3x plus 2. And I see that my x squared term is negative, so I know for sure that I want to move that negative 6x squared to the right side so it can be positive. And now I can decide whether I want to factor or whether I want to use the quadratic formula. Remember, if you're not sure whether this will factor or not, you can look at the discriminant. So the discriminant is b squared minus 4ac. That's going to be 9 minus 48, which is negative 39. Okay, that's not even a positive number, much less is it a positive perfect square. So I know for sure factoring is out, and so now I know I need to use the formula. So let's go ahead and assign a is 6, b is 3, c is 2, and we'll go through the formula. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, under the radical, we already know that that's going to add up to negative 39. So now we've got negative 3 plus or minus the square root of negative 39 over 12. Now 39 is 3 times 13, so that won't reduce except for the negative. The square root of negative 1 is I, so the I can come out, and we will end up with x equals negative 3 plus or minus I times the square root of 39 all over 12. And now let's look at this one. 5x squared minus 3x minus 2 equals 0. This one looks like it ought to factor, but let's make double sure by looking at the discriminant. So the discriminant is b squared minus 4ac, and I see that the discriminant adds up to 49. 49 is the square of 7, so that tells me that this can be factored and I won't need the formula. So I'm just going to real fast try to factor here. 5x squared would be 5x times 1x. The signs in my factors need to be different, and last times last is 2, so that's going to need to be 2 times 1. And now you can check outer and inner. Outer times outer is 5x, inner times inner is negative 2x. That's going to add up to positive 3x. I need negative, so I know I need to change the signs. And so now I'm sure my factoring is correct. Now I can use the zero factor property. If this times this is 0, one of the factors has to be 0. If the first factor is 0, then 5x equals negative 2, and x equals negative 2/5. If the second factor is 0, then x equals 1. And so our two solutions are negative 2/5 and 1. Now keep in mind that if you do use the formula when it wasn't necessary, then your answer is going to come out in a form that requires lots of simplifying. Not only will you need to simplify the radical, at the end of that you'll also need to simplify a fraction. So let's look at this example together. This is 15x squared minus 14x minus 8 equals 0. And I know for sure that it could be factored, but let's go ahead and do it by formula anyway. So let's say that a is 15 and b is negative 14 and c is negative 8. Okay, now x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Minus negative 14 is positive 14. Under the radical, negative 14 squared is going to be positive 196. Negative 4 times 15 times negative 8 is going to be positive 480, and that's all over 30. Okay, now adding under the radical, 196 plus 480 is going to give us 676, and 676 is a perfect square. So now we're going to have 14 plus or minus 26. The square root of 676 is 26, and that's all over 30. The first solution would be 14 plus 26 over 30, and the second solution would be 14 minus 26 over 30. And now I need to work both of these out. 14 plus 26 is 40, and 40 over 30 is going to simplify to 4/3. 14 minus 26 is going to be negative 12. So this one is negative 12 over 30, and that will simplify to negative 2 over 5. So our two solutions ended up being 4/3 and negative 2/5. Okay, so now see how much simplifying work we had to do? Not only did these numbers get really large, but we had to simplify that radical, and then at the end we had to simplify two fractions. Instead of doing that, if we had just noticed that the discriminant was a perfect square, we might have tried to factor instead of going through the formula. So let's try it by factoring now. 15x squared can be broken down into 5x times 3x. The last term is negative, so I know the signs here need to be different. And 8 could be given by 4 times 2. Now let's check our outer plus inner. 4 times 5 is 20. On the inside, negative 2 times 3x is negative 6x. 20x minus 6x is positive 14x, but we need negative 14x, so let's just change the signs. and here are our two factors. So if this times this is 0, one of the factors has to be 0. If the first one is 0, then x is going to equal negative 2/5, and if the second one is 0, then x is going to equal positive 4/3. So the same two solutions come out of that, but you can see that this process was a little quicker and the number stayed smaller than this process. So I really do think it's worth your while to build up your factoring skills and try to avoid the quadratic formula as often as you can.